Okay, guys, welcome. We're moving right up on the 11:40 start time. I've got a few seconds early, but my name is Mark Miller. We're going to talk about some guidelines for great design and some of the work that I've been doing in Azure and C#, and how some of that work can apply to what you are hopefully working on, or can hopefully apply to what you're working on as well. Let's start with this guy right here. I think I look a little bit like, what is it, Megamind, I think, if I was blue. Do you remember that guy, that character? A little bit like that guy. I've been doing developer productivity tools for 40 years. When I wrote this, when I calculated and wrote this down, I cried earlier. I used to think, it's getting better, and now I'm thinking it's getting worse, it's getting worse. But I've been writing code for a long time, specifically 17 years of that has been spent researching great design, user interfaces, user experiences. I'm essentially a self-proclaimed expert in that area. So if you have UI-related questions, I'm generally a good guy to ask on that. I've been working for DevExpress for at least 2 decades, working on developer tools. I've been a Microsoft MVP for about 10 plus rewards. And I've been doing AI tooling research for about 2 years now. And I do live coding on Twitch. You can catch me there. We're almost at about a show 1,000. So about 3 times a week, I am live coding in front of other developers who are watching. That's the main product that I've been working on for this time. We're going to talk about the core principles of great design, and normally this is a course that could take hours. We're going to kind of roll that up into a segment of this presentation. So I'm going to get you just the core principles with a few examples, and hopefully we'll see some nodding heads indicating that you're taking in some of that information. I'm going to present an alternate model for AI interaction based on my observations and what I've seen. I should also say I'm not an expert in AI. And certainly I'm definitely not an expert in the traditional ways of using it. And you'll kind of see the atraditional approach that we took and the reasons we took those choices. I'll talk about optimal context window filling and why it's important to have good data in your context window. Especially the further you're pushing AI, the harder you're pushing on it to do more intelligent things, the better the information it needs to be able to do that. And we'll talk about practical patterns of application. Okay? So, starting with core design principles. This is the most important one you can walk away with, which is efficiency is everything. I'm going to just move around a little bit so you're not looking at me from one place the whole time. Can I do that, though? Is that not working? Do I really have to be this close? Apparently I do. Okay. So we're going to talk about elements of your user experience. What counts as an element? Because the guidelines apply to the elements. And we'll talk about guidelines for presenting with clarity. All right, so performance. We talk about performance a lot, and then it kind of boils down into 2 different categories, real and perceived. We'll drill into these, each one of these a little bit more. You want to minimize physical effort, and you want to minimize mental effort, also known as cognitive load. So I say efficiency is everything. The first 2 things you can think about it is, well, I've got physical and mental breakdowns, right? And then from there, we can go and talk about how do we actually minimize those pieces, okay? So performance, real and perceived. You've got time for a call to return, a process to complete, a window to appear, and then you've got this thing that I call user steps, right? What does the user have to do to get the job done, right? And one of the ways we can measure that is how long does it take to do something, and how many steps does it take? I've got like one of these Ambilight TVs at home, and when I turn it off, I have to stand there and wait 4 seconds, because after 4 seconds, it turns on the Ambilight around the edge, and I have to hit a second button on the remote. right? So it's added 2 additional steps just to turn it off. Normally, when you turn things off, since 1950, you hit the switch and you walk away, right? And so that's an example of an extra user step. I've got a massager that to turn it on, I have to push and hold the button and wait about 4 seconds before a light goes on, and then release and push again. And the button requires some force as well, so my finger's a little bit like this when I do it. So we're talking about duration and length. Can we make these 2 different experiences shorter? Yeah, we can do that. The time to perform the steps, so in both of these examples, 2 of those steps were about 4 seconds each. And then minimizing physical effort. So we've got mouse moves and key presses. You've probably heard about this before, right? How do we, do we want to apply any effort to UI? And if we do, what should we apply it to? Well, we should maybe, allow people to do this in fewer steps. Eye gaze shifts is actually super important. If your application has somebody making a change up here, then looking down there to click a button, then looking back up here to make another change, right? My eye gaze shift is big. And I want it, if I'm looking here and I need to tell them something, I want to put the information near where they're looking so that I only am I can even see it maybe right there still in my fovea, right? The fovea is the back of the eye, the part where we see everything with crystal clear vision. With voice, one of the things actually I like about using voice with AI is that I can say something like this and I'm done. So in terms of effort, I don't have to put out a lot of very descriptive information. I can put out something almost cryptic, almost a clue, and AI will figure it out. It'll put the pieces together. Now, when I say it'll figure it out, we're also supplying a context window that gives it the information it needs, right, to be able to figure it out. As an example of fix this, I might have a method that does a bubble sort, for example. And I might say, is this the best sort? Like that. And it might say, okay, here's your new sort for that. And it can do that kind of thing. So you have a very conversational interaction that's low on number of words, low on word count. And then user steps comes back again. Duration and length shows up again. But under physical effort, you also have force, right? Now, in the software world, force is pretty low. But even on keyboards, if you guys are using keyboards, and at the end of the day, your fingers are a little bit sore, you might switch to a keyboard that has a lower pressure requirement to push the keys down. And if you have, you may realize, oh, I've found relief out of working with a keyboard that's, not so perceptible with each click, but by the end of the day, it adds up. And now I'm using less effort for the day. Okay? Also, device transitions, keyboard to mouse, mouse to keyboard. If you require me to click somewhere, and then you require me to type something in, and then you require me to click again somewhere else and type something in, I'm transitioning each time. Each time I'm lifting up my arm, putting it down over here, lifting up my arm, bringing it back. There's slowdown between each of these. The point is, if you're on the keyboard, let people stay on the keyboard. And if you're on the mouse, let them stay on the mouse, right? That's kind of what we're looking at. If they're using voice, let them stay in voice. So I've got some examples. Minimizing mental effort. I've got precision is bad, concentration is bad, noise is bad, frustration is bad, and then user steps down in here. We've got duration and length shows up again, but also easy or precise, right? Is precision required? So like, for example, Windows Explorer has got a preview pane, and to the left of the preview pane is a splitter that's 3 pixels wide. So I'm bringing my mouse in there to grab that splitter to adjust the size of that. It requires precision to get right in there. And as I'm honing in on that, right, my cognitive load is going up, right? You cannot have a satisfying interface that requires precision, concentration on the UI, noise, makes you frustrated. Those 4 at the top that are labeled as bad, if those are in your application, it cannot be satisfying, right? We can't come back away from that and say, no, that was a satisfying experience because there was something wrong with it. I have this picture here because I love the size of this button. This button is about like that big, and you can just hit it. It's also interesting because it says accessible, but I don't need it because I'm in a wheelchair, but I love it because I don't have to concentrate, right? I'm just like, boom. Look, it's the only button to get in. It's not like I've got 4 or 5 other buttons to choose from, right? Similarly, if I'm in an elevator, creating a button that's big to get me to the lobby makes a lot of sense, because half the people who get in that are going to the lobby. Half of the times, the button I'm going to press takes me to the lobby. Okay? By the way, kids, you saw at the beginning, my name is Mark. You can stop me at any time. Am I going too fast? Too fast? Everybody's okay. All right. You can stop me at any time. You say, Mark, that makes no sense. Mark, you're a fool. No, I disagree. You can say whatever you want. I just want to, if you have a conversation, I'm totally into it. Okay? So elements of your UI, you've got sensory elements, which are sights, things you can see, right? I'm including the background. I can see this background. That's an element, right? Lines, text, links, buttons, graphics, images, etc. Everything I can see is an element of the UI, so the design guidelines apply to everything. What does that mean? Well, you'll see a rule up ahead that's violated all the time for lines, right? At one point, even large companies would come out with products that say, here, you want to pick your background graphic that we're going to throw behind things like buttons and stuff, right? And you'll see how things are like, wait, that's wrong, according to Mark, at least, right? So you'll see that. Sounds can be in this group as well, right? Beeps, signaling, sound effects, voice feedback. Cool. All right. Actionable elements, this stuff you already know, but basically we've got some sort of inputs and some code behind the inputs. So my UI is what I can sense and what I can act upon. All right, presentation guidelines. I've got a whopping 2 guidelines. These are the most important rules, and they are broken all the time in bad UI. Okay, number 1 is emphasis matches relevance. If it's important, you can make it emphasized in a way such as here, I've got these bolded. Okay? The words are bolded. That means it's emphasized. They are in black, which is high contrast against the background. Notice this bullet here is low contrast. It is not important. It is not emphasized, right? Relevance, also bolded, because it kind of connects with emphasis. Does that make sense? The bullet point demonstrates the bullet point. Okay? Proximity in both space and time. What's interesting about these rules is they apply across dimensions. Proximity in both space and time needs to match relatedness, meaning how closely are these in common? How is one related to another? I'll give you some great examples of this in a second. So here's mostly good on this page right here. Here, the option is bigger, so that's emphasis. I can emphasize with size. It's higher contrast. I can emphasize with contrast, right? Here, the button's in the off position. I am de-emphasizing, right, by making it lower contrast, making it closer to the background. Down here, smaller font, lower contrast. See, this is like a gray on a dark gray, right? So this is easy to read, and this is like a little harder to read, right? But that's okay because it's not as important as this, right? This is an older screenshot. There's a couple things that are, I don't know, maybe arguably questionable like that, but I'm not worried about that. On the other side over here, same thing, 2 different versions, light theme and dark theme, where you've got emphasis that's happening here, right? Almost, I see this happening all the time. Even AI does this. AI will give me something like this where I have data like this, and it'll bold these guys, not that data that's important. Right? And I think even there, I've bolded the numbers, and I've not bolded the units. Does that make sense? Any questions on that? Everybody okay with that? Not too controversial? Okay? All right, good. This is real simple, but I love it when websites do this. Hey, wait, I want you to focus here. Right? We're de-emphasizing by lowering the contrast everywhere else. A quick, easy way to do that is throw up a half gray at 50%, something like that, or black at 50%, screen on top, okay? Just simple and nice. This happens sometimes. Trucks are too big. They go into tunnels that are too small. This I love. It's a rain curtain. It is, it's got a lot of contrast, a lot of brightness. It's very big in terms of emphasis. It's very important. It also matches it solves the proximity guideline as well, in that it's related to this place that's about to destroy you, and it's right inside it, right? You can't get any closer, right? So that proximity is satisfied. Okay, proximity matches relatedness. So if you have things that are unrelated, like Monkey World and the Tank Museum, you don't want those to be close together. Or if you have nuclear power plant and the spider farm, right? We don't want those close together, right? So you want to be thinking about that, because you know, and sometimes user testing reveals that maybe I got this, which really has nothing to do with the base of the lamp, right? I got it maybe a little bit too close. Sometimes you can get into a proximity problem and you don't realize it until after you've gone down the wrong hallway and you turn back around and you look at the sign again, right? Notice these two are closer together. And as humans, by the way, I didn't explain why these guidelines exist, right? Why is it that if I emphasize, why is it that emphasis should match importance, relevance, right? Well, because we've been living for about 200,000 years, right? Evolving for about 200,000 years, where if something is very loud, or something is very big, or something is coming at us fast, or something along those lines, we pay attention to it, right? And if something is not, we ignore that, right? So our brains naturally pay attention and give more weight to things that have greater visual weight, right? Similarly, if things are close together for that 200,000 years, if we looked across the field and we saw a couple people standing together and another person standing far away from them, we could infer something about their relationship, right? So we naturally, in the natural world, we see, our experience shows us that if things are close together, they are related. So we look at this sign and this arrow, they're all together, right? And we look at these, they're all together, right? And so we go, okay, well, let's go to our room number, which is 1523, and we go to this way. And we look, and then we come back this way, and we realize that this grouping is the grouping they've intended. And that one is the grouping, right? Other similar examples here, right? Which way to Dallas? It's not that way, but it looks like it might be. Which button for 18? Right? We may not know there's a problem. We may just think, oh, okay, and we click, and we open up, and it's like 19, and we're like, what? Right? And we might not even think about it. Right? But these are all violating this guideline, right? They are close, the pieces that are close together. This should be here, or whichever one it is. Notice I cropped the outside edges, giving you an impossible task, right? If I was the devil and I wanted to mess with you, I'd say, well, just pick a room right here. One will be perfect and the other one will be horrific, right? And you're like, wait, where's the edges? I want to see the edges. Oh, sorry, I'm the devil, remember? The devil made this one right here. So this doesn't, at first glance, you're like, wait, what's wrong, right? But if you look in the middle, I've got 1, 2, 3 like this, and then I've got this one, which corresponds, I have to look at it, to this one, right? We know this is connected, but this one, which is closest to that one, is not connected to it. It's connected to that one, and this one's connected to there. Make sense? It's a problem, okay? This one is actually, it's kind of recent. This is a major car manufacturer released this audio player, and this is a button for sound, this is a button for band, this is a button for tuning, and this is a button for presets. But it's not a touch screen. I can click, click, and click as much as I want, and nothing will happen. Where are the buttons? Yeah, they're over there. These are the 4 buttons that map to here, which means these two that are close together are wrong because they're not related. This goes to that one. This one is for presets. The mental math I have to do in this car, right, as I'm learning this or figuring this out, is substantial. It is not okay to do this to people, okay? All right, so Everybody take a breath, mainly me. That was a collapsed version of a much longer, more detailed presentation, okay? All right, an alternative model for AI assistance. Let's look at this. So this is the model. Basically, it starts with you asking a question, like fix this or do something. Then we go to a tiny, fast AI. And that tiny, fast AI gives us some information on what context we need to put in the context window. And we assemble that into the context window. Will this work from there? There we go. OK, great. Then we take it to an advanced reasoning AI. We take the original question and the context and send it here. Then we get back the answer, and we're asking, we in our implementation are asking for very specifically for only the changes. We give it a way to map the changes and only give us the changes. Why? Because complicated answers or to complicated questions take time. Each token takes a long time to generate. It doesn't take as long to read it, for it to input it, but it does impact output speed. And so we're trying to get the answer as quickly as possible. So we say, just tell us the changes, the differences. Then we go in and automatically integrate that into the data, apply the response. So that's what I'm calling the alternative model. Why do I call it alternative? Because most models are like, hey, I want to do something. OK, let me work on that. I'm going to go talk to some MCP servers right now. I'm going to get that information. I'm ready. OK, I got it. I integrated. I just compiled. And oh, I've got some changes or got some problems. Let me go fix that. Let me go working on that. I'm working on that. OK, great. What? Oh, I didn't like that. I want to do something different. Like, OK, all right, I'm working. So it's this chat-based discussion. Right? The chat-based discussion is where? It's in a chat window. The chat window, is that my application? No, it's off to the side, something new I just added. Well, what happens now? I'm working in, your customers are working in your data over here. Now we want to invoke AI. Oh, now I'm going to a chat window, and now I'm going to have the whole discussion. So I think basically implementations of AI fall into two categories. Either you stay with the chat discussion, that's the default response I see a lot of folks doing, or you go into kind of a stateless, just ask the question, and it gives you an answer right there. 1, 2, 1, 2, those two. And what we're doing is a little bit different from both of those. Okay? Any questions on that conceptually? Is that making sense? Yeah. This was all theoretical like several months ago, right? I was like, I think we can get all of this to happen in less time, improving the quality of our answers, than it would really take to if you took our current one and doubled it or something like that. And the answer is, it seems to be effectively that's the case, is that this impact here is marginal. It's still a portion of the time it takes for this guy to answer the question. Okay? So we can call this A4 model for short if you want to. All right. And then on top of this, we just add usability optimizations. All right. OK, so this is a little more detail here in what's going on here. So we start with the AI context query. This is where we go to the little guy, and we say, you're not going to answer this question, but you're going to tell me what I need to answer the question. And we have a kind of a flexible architecture here. I'll keep going through the slides because it'll show you what that looks like. Then we go into context collection. And so context collection basically can get from a variety of sources. We can actually reach out to MCP servers during that time. However, these guys can be slow or may have big results. Since we're a source code modification tool, one of our context collectors can get source code from the solution and grab that and assemble that. We notice I've got chat history up there at the top. We can, if it makes sense, go back into chat history. But we don't have to. By default, we're stateless, unless you say something like, no, that was wrong. I didn't like that. Let's do it this way instead. In which case now it would be a good idea to give some context. So each one of these here, and there's actually more of these, but these are just kind of example ones. It's an implementer of an interface. That name doesn't matter because it's the one we invented. But it's an implementer of an interface. And these guys also participate in the first step. So everybody, so when a customer asks the question, we go to these and we say, what are your instructions? Are you enabled now or not? And it looks, each one of these looks at it using essentially heuristics, like looking for keywords. Like if I say Microsoft in it, this guy says, oh yeah, I'm good, I can get you Microsoft Docs. I'm in, I'm allowed, I'm in. If I say DevExpress, the DX one says I'm in, but if I don't, it's like, it's out, you know? And if I say something like, no, I didn't like that, or whatever, you know, that's wrong, or let's try something different, anything that alludes to a previous history of discussion, chat history says I'm in, right? Then what these guys can do is they can say, here are your options for the tiny guy that we're sending to the tiny guy. Here's what you can pick from. You can select the last thing I said, the last two things, the last three things, that sort of thing as an example, okay? Type source can say, here's the code that the customer's looking at right now. What do you want to grab? What do you want to look at in there? By the way, if you tell me an interface, I'll grab all the descendants as well and pack them in, right? Just so that we have a rich set of information. If you think an interface is important, then I will do extra work for you, heuristically, by saying, I think descendants are important, okay? So basically, you've got an import many method on these guys right here. Here's an example of what our interface implementer looks like. It's got a call to get context, and it returns a list of something called a context slot. Now, I said the names weren't important, but I've got some sample code I'm going to give you a link to, and I've included context slot in that. So you might be like, oh, Mark says maybe context slot's important to think about. It's pretty simple. It looks effectively like this. It's got a priority and a list of fills. Why does it have a list of fills? It's best to answer that question visually. There are three to five different sized versions of the same context. In other words, if I make a call out to MS Docs and I get documentation on something like using Azure Speech Services, I'm going to take that original doc and I'll say, okay, I'll put that in the fill, but I'm also going to take a shorter version of it. Maybe I'll take out all of the links, any kind of image references, you know, clean things up even more, and maybe I'll take another version of it where I say, well, I'm only going to take the first couple chapters or something, whatever. I just cut it up into 3 different pieces. I'll explain why in a second. And for those of you thinking ahead, you probably figured it out. Optimal context window packing. Here's where I take my limitations of the AI model. It says my context window is this big, and I take my context, which is like that big almost always, and I try to get it inside to fit. That's what's happening there. And I send all of that to the main AI query. That's what's going on there. By the way, there are other things that we can do in here too. Like we can have a participant that doesn't really supply context, but what it does is it listens to what the tiny AI says. And it can tell the tiny AI, like it can give it a command. So I've got a command, and the command is, you want to tweak verbosity on this next call? And so the command can say yes or no. Now how does that make sense? Well, or how is that applied? As a developer, I might say, I want the next answer. I want you to use minimum reasoning effort on it and have verbosity, though, at a maximum. So I could say a sentence like that, and that guy could send its information to here, to the tiny one, and the tiny one can be like, oh, okay, so that means we're going to set verbosity on to high, and we're going to set reasoning effort to low, or minimum. Make sense? And we're actually now tweaking things based on what you said in the query. We're tweaking things. It allows you to change settings or even change model, right? You could say, I want this to go into a fast model instead. And so we bypass, right? So these guys here, they participate in forming the prompt and in collecting the context, right? They're both, all of these are individual experts at that stage, okay? I added here UI to speed the wait time. Then we have the Delta integration. And this, by the way, is fast. This generally happens even if we're making large numbers of changes across files. It's about a half a second to a second. So this part's not the problem. We also give you 1 step undo on that, too, for customers. So if I'm making multiple changes, bum, 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 I have 1 step to get everybody out. And that allows us to do this change first and then review, right? Which is my preference. I think it's a little bit faster than, let me show you all the changes, and now you have to go through and manually approve each one. Okay? And so after we integrate, we have the navigation review. I'll show you all this live here, but that's basically the breakdown of it. So fewer steps, less waiting, cheaper AI costs, right? So you're sending fewer tokens because you're asking for deltas. You're getting fewer tokens back. Is there anything on? I don't think there's really savings on the submission, but the cost of the tiny fast AI is about 1/10 of the cost of the big guy. Is generally what the cost changes are there. So lower environmental impact, and user stays close to their data because there's no separate window to go to. They're inside the code. And I didn't really explain how we're doing that yet, but luckily I've got this voice prompts slide up here. So I'll start by saying I do not work for Azure. I do not work for them, but I'm probably one of their biggest, their speech services, I'm probably one of their biggest fans because I'm telling you, this stuff is amazing. It's surprisingly fast. So that 420 milliseconds, when I stop talking, it's 420 milliseconds before I get the full translation that comes back. That is a reasonable amount of time. If I've spoken for like a long, long paragraph, it's 420 milliseconds about. It doesn't change because it is translating to text as I'm speaking, right? So it's a fast response. We get right back into it. It's impressively accurate. I'm saying it's 99.9% in that these are the times I've noticed it's gotten something wrong. It usually gets something wrong. Well, the only time I notice it getting something wrong is when I use voice to rename an identifier. Because then I'll speak in kind of code, a mystery kind of way of speaking that's not grammatical, right? I might, say, the only one I can think of is an actual sentence like, I can see clearly now. So that's, clearly my brain's not working with a great example. But most identifiers aren't, and sometimes it'll switch in a homophone instead. It'll get the sound right, but or switch in a homophone. So renames are the times I've noticed it being wrong. It works really well in noisy environments or with loud music, right? I can turn the music up to the point that it's like a little too loud and like almost hurting, and the microphone's right here, the sound's filling the room, and I can still talk, and it comes back understanding what I said, and I'm just like, my mind's blown on that. So how to trigger? So this approach is, by the way, I had the word lame up here before, and I took it out to say suboptimal because I felt like that more accurately, well, the lame reflects my emotional attachment to that approach, and the suboptimal is like the more accurate, truthful response on what I think about it. It's always listening and trying to infer intent all the time, likely to increase false triggers. Push to talk, better. But how? There's no voice dictation key on dev keyboards, except for this guy on my new keyboard I bought yesterday. However, this seems to be inherently tied to the operating system, and it's push on and push off. So it's not quite push to talk. So if you do try to use that key, and not all keyboards have it, if you do try to use it, you're going to have to bypass the operating system response and I'm just not into it. I'm not into a push to talk, say the thing, and I forgot to stop and hit it again. I'm much more into hold down while I'm talking and then release, because as soon as I release, that's that 420 millisecond time, countdown time, right? The faster it's going to get to work for me. So this is our approach, how we made this work. We're using the control key, and up here at the top, I've got time flowing. I've got an animation I'll play. When this blue line drops down to here, the control key is down. The control key is up when it's up at the top. This guy will start speaking at some point, and here's how it works. And you can watch this right here, because that's going to, there it is, down and up. So we do a tap, and then we push down again, and we say it. I want it to be intentional, right? Because we are about to call a service that's going to cost somebody some money, right? So I don't want to have an accidental, misfire if we send that out. Okay? That's how that works. So it's a tap, hold. Any questions on that? Everybody good? Yeah. What about what?
For a mobile device,
Mobile. How would I do it on a mobile device? Well, I guess on a mobile you could have a button to do it. What is it? Yeah, no. So on a mobile device, well, it depends. It depends on. So if let's say there were some consequences in starting the action, and you wanted to slow it down, an easy way to get past the consequences and to really show intent is to click and drag something from one spot to another, right? They have the slider, like here's, you want to turn off your alarm, click and drag it, right? So that is a way to do that. But it may be that you can just, that's not a concern and you just have a button and you say go, but it's a dedicated button. The reason I did this is because there's, in a mobile device, I'm assuming you have your app, you've got control over the UI, so you can put a button there for dedicated this, but on a physical keyboard, I can't do that. So that's why I have this. Does that feel like a safe, fair answer? Fair answer? Okay. All right. Okay. A lot of people, by the way, when we say it's voice activated, say, oh, good, that's accessible. And they kind of use the word accessible and they dismiss it. They throw everything else away. And it's just like that button on the side. And I want to just remind you of that button because that, while that may be accessible, you may view it as accessible, it's easier for everybody, right? Accessibility often turns out to be easier for everybody. And if it's easier for everybody, we're getting closer to satisfactory UIs. It's also a surprising natural fit to LLM-based AIs using voice. LLMs are tolerant of mistakes and even reversals or corrections. I've used the feature that I'm going to show you, and I'll be like talking, and then I realize, no, wait, you know what? I want to do something different, and I keep holding, I'm still talking. Let's do this instead. Let's change the thing I told you about here to that and this and this. I release, and I'm like often amazed that AI does only the thing I corrected, right? It doesn't do the other stuff that that were mistakes early on. So it's very, very tolerant of these reversals or corrections. They're also great at inferring intent. I can talk about the thing I want to do, right? I can say, hey, I want to move this method into the class that this descends from, or I want to, there's an interface that I'm using that has methods about storage. I want to create some test cases for everything here that works with that interface, as an example, right? So you can kind of talk about it, the things you want. And LLMs are great at figuring out what that intent is. I have this example here. Implement the eye candy sign interface, right, as an example of figuring it out. And by the way, when you use voice in our product, when the prompt goes out, we include a little piece that says, this was dictated using voice, so there may be things I'm referring to by sound, by the sound representation of it. Okay, makes sense? Yeah. All right, so optimal context window fill. So complicated requests require sophisticated context, and sophisticated context in our world always blows through the context window, right? I have a solution with 15,000 files in it, and just listing the names of the classes in that solution blows out the context window. It blows it out. Just the names, let alone the source code, right? So our approach, talked about this before, the double query set. Initial one, what information do we need to answer this question? Second main query includes the context collected. Quickly create a set of alternate sizes for the context elements. Dynamically pack the context window based on priorities and available elements. And it's kind of a little bit like this. We have a bunch of these varying size pieces. We talked about this already. We make context collection extensible. Each context slot is like stacking dolls. So that's a context slot, that's a context slot. We're going to try to fit them all in. Remember, they have priority. So it's also up to that tiny A response to infer priority by saying, I need this one and this one and this one and this one, and that infers priority for us, right? The first one responding is going to be the highest priority. in general. But there may be overriding things because of what we know about. So here's an example of like an original piece of source code, and here's an example of a tiny version of that same source code, right? So we just create these very quickly, and we actually have different, we've got like I think 4 or 5 different source code sizes. And we'll actually create like all 5 of those, original size plus the others. And if you've got room for the original, we'll give it to you in the context window, and if you don't, we'll drop it down. Here's the source code right here, GitHub Miller Mark context packing. Let me bring that up and show it to you. This is the app right here. And so I can come up here to the slider, and these create more context slots like this. And then this is my context window, and I can just dynamically change it. You kind of see what's happening visually here, right? Its goal is to try to include as much context as it can. That's essentially the goal. What can we pack? And as I start dropping the size of this down, you see it's grabbing the other variant sizes of each of these contexts. So like D's got D7 there. That's the smallest size D7 can go. So if I keep going, now at some point we're gonna start dropping. D7's still there, look, it's truncated right there. So that means we're truncating it, now it's gone. We've dropped it. And so you kind of see what's happening here is we're trying to bring these pieces in. And then finally, we're out. We're totally out of room. But that's kind of what's going on. So these are, in this sample, it shows the number is the size of the context. And so the I8 has got basically 8 by 8, some ratio compared to this 10 by 10. That's how it works. Any questions on that? Okay. Practical patterns. Okay. All right, A4 model. Wait, actually, before I go into practical patterns, let's actually watch what I've done and see how well that works. Let's do this. Hey, can I create a new fraction class with a numerator? Oops, let's try it again. Can I create a new fraction class with a numerator and a denominator? And so there's some UI showing up right here. Can we turn down those lights right there, by the way, in the back? Is that possible? So we get greater contrast up here. All right, so I've asked for a fraction class. Now you heard it for a second, it said there's some feedback. Creating it right now. So that audio feedback is actually really, really good because we're about to start a process that could take some time. And telling the user, I heard what you said and here's what I'm doing, right? It gives you a sense that everything's still going the way I want, and it sucks up some of that perceived time that I otherwise would be watching, right? So here's what it's given us. It looks like there's an argument exception here that it can't find. I'm just going to do a using system on that. That should fix that up. And there's the class. Now down over here, I have the navigator that shows up. And there's just one change inside of here. I can open that up and essentially see the same of what I've already got. Okay, so we've created this in here. Let's take a look at the class, and we'll kind of keep working with this a little bit. So we've got a divide by 0 exception in there. I'm OK with that. That's pretty good. Let's change it now, though, because, or let's maybe, yeah, OK, let's change it. Let's make it so that when I create a new one, it's always simplified. So that's the change we want to make. Hey, when I create a new fraction, I want to make sure it's always in its simplest form. So now it's forming the context.
I'll ensure the new fraction is created in its simplest form now.
And there it is. And so now what's happening here? We're not moving out to another window, right? We're not. We're not typing anything in, right? I'm holding down the key, the control key while I talk. The force required isn't a lot, right? So we're following a lot of these UI principles of good design. And now what has it done? Okay, now it's got this GCD is equal to GCD, whatever that is. So probably greatest common denominator, I think, something along those lines. And looks like that's set that up. Great, now let's add some operator overloads to it. So let's just keep going, right? So we can just do, hey, can we add some operator overloads to this? And maybe while you're doing that, also create some implicit conversions between real numbers and fractions. So now I'm expecting an operator overload for plus, minus,
I'll add
divide.
the operator overloads and implicit conversions for the fraction type now.
By the way, the caret's there and the feedback's there, right? So where I'm already looking in the code, it's putting the feedback right there. So I don't have to move my eyes, right? All right. All right, so there's the code that it's added there, that you can see what's going on there. We open this up, we can see there's the overload. So we've got the plus, the minus, the times, divide, great, and the implicit conversions. Sorry, not yet. Hold on, those were comparisons. Here, we'll just close it down and look at the source code in here. There's the implicit operators right there, conversions. Okay, let's do something bigger now. Hey, I'd like to create a new interface called I Can Calculate. And I wanted to take two doubles. And I want it to return a double. And I want you to create like 10 implementers of this interface that that represent common mathematical functions that work with two numbers and return a third. Okay? So I kind of fought my way through that, right? It was certainly not precision in terms of
creating multiple implementations of the I double binary operator interface for common mathematical functions now.
I double binary. I thought I said I can calculate. Interesting. I wonder if it changed it, or I wonder if we're going to get something that says I can calculate, because I think that's what I said. Yeah, okay, so big AI got it right, little AI got it wrong. Only in the feedback, though. Okay? So here's what it gave us. Hypotenuse, modulus, average, max, min, power, divide, multiply, subtract, and add. So it gave us the subtract and add ones as well. Great. Let's see if we can push it even harder now. I'm now going to ask for a change to the ancestor, to the interface from here. So I'm here in the code. I'm going to ask for change to the interface, and I want to see it plausibly implemented throughout the rest of all of these 10 that we've created. Okay? I'd like to add a name property to the I Can Calculate interface. And I want to see it plausibly represented or implemented in all implementers of that interface. So now we've got a kind of a more complicated situation, right? I'm talking about making a change to one file
Adding a name
that
property
impacts,
to the I Can Calculate interface and its implementations now.
and it's got to find all 10 of those to be able to get it and make that change. And hopefully we'll see that. Okay, cool. So here's the response from this, and if we bring up the difference view, you can see what it's done here. It's basically, there's the name right there. I can just hit F8 to go through each one of these all the way down there. Now, I'm noticing that it's taken out. This looks like, I think you could argue that's a bug right there. So if we don't like that, that's something that shouldn't happen during this, but you can undo and we can do it one more time. But sometimes the response that comes back is potentially a hallucination. You can maybe argue that's the case here, and in which case you get a chance to see it and you get to undo that if you don't like that. Because that's the thing is, sometimes we're dealing with AI and AI might say, well, okay, I want you to replace the class, but what they really maybe should have said is used a different response, which is add the member. Something along those lines. But the good news is up here is it's implemented each one of these names across all of these different files that are in here. So it's that example of making all of those changes. Any questions on that? Good? Good? Yes? How is this in Visual Studio? So this is part of CodeRush, which is an extension for Visual Studio. That's what's happening. Yeah, and so actually this is a great question because there's something else that's happening here. Is that, and in fact, what just happened is actually a great example of things that are happening where we take what comes back from AI And in our case, our document is source code. So we'll take what's coming back and we'll check it to make sure when we integrate it, is it all syntactically valid? Can we at least verify that? And if it's not, we'll throw an error and we won't change the code. So we can do some validation, and even we can also do things where we find common hallucinations and get it back on track. So our hallucination adjustment code and our validation code is like this in my mental model. It's big. And it kind of grows. It hasn't grown a lot recently, but this is like an interesting situation here, right? Where I did not ask it to remove these, and it looks like it came back and said replace the class. And when it said replace the class, well, we say, if you don't tell us to do just the body, we'll replace the whole thing. So we are basically doing as instructed here is what it appears that, to have happened. Okay, ready for the last set of slides? Okay. So actually, things that, I just want to go back to what I was saying before. That work that we do to get AI back on track is work that you'll likely do in any application, right? AI is unlikely to give you that same perfect response every time. And so getting that, finding out where it's likely to veer off course, and even anticipating it, I think you'll, once you're working in that space, you'll be able to figure that out and say, okay, we just created this part of our spec. Is AI likely to misinterpret that and go in one of two directions? And now, like, the team is like, yes, let's handle both directions in advance, as an example. So, yeah, and these are the kind of discussions I like hearing on the team, right? Well, what if it comes back this way? Should we anticipate that? And generally, the approach is yes, we should anticipate that. So, all right, here we go. So the AFR model, dynamic context collection, priorities, we have prioritized context slots, optimal context window packing, and including rich context from your environment can reduce the user prompt burden. So this is huge, but this is like something I don't know what your environments are, right? But for source code, we got this, right? What we're doing is we're like saying, well, let's tell you all about the project. So you know what the language is, what the .NET framework is, what the UI framework is, right? We tell you all about that information. So the code you generate, big AI, is going to be appropriate for where it's going. So you can do that same kind of thing where you include that rich context from your environment. Yeah, you're looking for opportunities to drive the prompt context and key properties of the big AI query from the little one. Answer immediately, fix this. Why is this failing? I need test case based on the live data. I want verbosity high and reasoning effort low. Take a look at my clipboard. By the way, I should say, so the stuff that I showed you, some of that is not shipping yet. It's stuff we're actively working on. So if you were thinking, wait, where is this? How can I see this? You might try, and it won't be. It may not be as everything you've seen here today. Okay, on 2, voice. Input is almost always much faster than text, right? So if you're trying to optimize productivity, right, to try to do the demo that I just gave you by typing in would be difficult. Even to try to do the demo using the native voice recognition, which is on the machine, which is not as good as Azure, right, would be slower. Right? So if you're talking about optimizing the productivity of your user, voice is something to consider. You can also do voice feedback, as you heard examples of that. You get an easy free win in terms of compressing perceived wait times. So I love that, putting that feedback in there. I feel like it's essential to the pattern, right, that voice feedback. Fits well with the model. Also, easy support for 100+ languages. So in the version I have right now, you can go say, what language do you speak? And ask for your source code in Portuguese or whatever language you want to use, whatever your native language is. You can also choose what language do I want to hear feedback in. So those things, and when I say easy support, I did nothing other than create the UI, right? Azure gives me that for free. Have I told you I'm a big fan of Azure Speech Services? Have I said how awesome this service is? It is so good. If they wanted to hire me, I would do it for free. I would refuse a paycheck. The push-to-talk mechanism, I think, is essential as well, right, to make this work. Clicking a button is a little bit harder to do. It's really, I feel like we've really distilled the effort required down to its smallest form factor in our implementation, right? There's really not much room for making this better in terms of what user responsibilities are. I recommend the Delta change integrations and or command interpretations. In other words, give AI a shorthand for the response. Tell it what you want to do. Tell it what the format is for the response. And then we're only doing changes, if that works in your world. Yeah. Yeah, I think I think the answer is yes to that. In the context, so the question was, can you work with NuGet packages? And the answer is essentially yes. So if I were to go in right now and say I want to create an application that allows me to speak in English, when I click a button, I want it to create an MP3 file in Portuguese. If I say that, it's going to need to bring down a NuGet package. And so what happens is that UI in the bottom right says, so it generates the code, and the UI in the bottom right says, you might want to install this NuGet package. And then you can click that button to install it, or it might have a list of packages. Okay? So it doesn't do that installation. That's a manual step, but I'm okay with that for now. Yeah, so that's how that works. Let's see. Make all changes immediately. So there's this is kind of philosophical difference that I have with the Microsoft teams. But Microsoft basically says, I'll list your changes and give you a preview, or I'll change one at a time, and you preview it first and say approve, which is great if you're worried about getting sued, if you're worried about if you've got mission-critical applications where changing that source code is going to kill somebody if we or lose money or something along those lines. It's a very safe approach if you're talking to a lawyer. But if you are a developer who's trying to get work done, you actually can get more work done and spend less time if I'm not forced to approve every time before I execute. The reason why is because sometimes the change is so small I can see it immediately at the end, or I can run my test cases immediately. I can find ways to approve without thinking, right? Yeah. Wait, say that again? Oh my God, I'm so glad you said that. Actually, I've got a slide about this, yes. We'll talk about this in a second. We'll get to it. We're 3 of 6, and I got 2 minutes and 44 seconds to get through these. So, and we'll do all other questions at the end, just so I can get all there. So basically, all I'm arguing is sometimes the approval is effortless. You can see the code, or I can run the test cases, or I can run the app, see it and verify, right? And I don't need to actually look at the code and click OK. If I force everybody to look at the change and click OK before, there will be some times where that could have been faster. That's why I say, for optimal user efficiency, make all changes first, and then give somebody a way to look at diffs, to look at the changes that have occurred. This one we talked about already. Validate the correctness of the reply, if you can, and repair hallucinations. Yeah. Okay, and then I say, hey, if you've got a mission-critical application where any mistake can be deadly or costly, you don't have, and you don't have undo on that, then don't do this guideline. But otherwise, it's not bad, especially if you give them a single undo to get all the way out, right? If I see something I don't like, undo. Try again. I talked about this, the feedback while waiting, color-coded, motion-coded status. So if you look here, let me play this really quickly. Where is it? Right there. Boom. Okay. It's listening, and there's a little animation here. You can maybe see it. It's a little bit of animation. Then it goes to thinking mode. So it's blue, it's purple right now. Then it goes to thinking, context collection, it's teal color, and it's active, right? And then we go over to the big UI, and it stays active but changes color. So I'm telling you what's going on in a very small amount of space right there. Okay, over here. Visual feedback and close spatial proximity customer focus. So if my carrot's here, my cursor is there, that's where we're going to put that feedback. Also, voice feedback in close temporal proximity to the end of the user's question. I say, here's what I want to do, and it says, OK, immediately. Here's what we're working on. Easy to deliver localized support, and cancel button is important. Okay, 5 and 6, keep UI close to the data, avoid separate modes, avoid the other window, going back and forth, if you want to emphasize productivity. Okay, give people agency over the process, give a single step undo, cancel button, detailed logs for auditing, right? A lot for compliance and indemnification policies, that's all important. Tweak prompt and functionality settings after the context query. We talked about that, where I might say, hey, use full verbosity. Don't reformat the code after generation, might be something I say, for example. And that changes what we do afterwards or how we integrate. I want a verbose response with maximum cognitive effort. Triggered prompts. Triggered prompts are an idea I came up with. I got 14 seconds. I'm not going to tell you because it's not that great of an idea. Logging, just the AI service providers offer indemnification clauses to protect you against claims of copyright infringement. These clauses require proof that the code in question came from AI, so you want to log. You want to keep a detailed log of what has happened. Other advantages, it documents the spec and user intention, right, which is actually kind of more important than the code, right? I was trying, sorry, when I say user intention, I mean, in my case, I mean developer intention. And that's it right there. Those are the advantages. Thanks so much, we got out of it. We got through it. And come on up while I shut down if you've got questions. Thanks so much.